Okay, so in this section, you guys are going to be looking at how there is more than one way to write an equation to represent a situation, how writing an equation can compare to solving that equation, and you'll see in these ones that it's really worth us looking at the algebra part of this to be able to solve these different problems. Okay, in the explore activity, we're going to go over the first two together. So I'm just going to have us do A and B together. We're not going to worry about C or D. The first one says, and on these we're just writing the algebraic expression that we would use to represent the situations. And really what I want us to think about is how A is different than B. So in part A, it says increase a number by 5. So if we just look at that part, if we were to increase a number by 5, we have x as our number. We would write that as x plus 5. And then it says to increase it by 35%. So when we are increasing by a percent, we're going to have 1 plus the percent as a decimal. So if we were decreasing, that would be 1 minus the percent as a decimal. So for this one, we have 1.35. And it says, and then. So with this one, we know that we're applying it to both the number and the 5 that was added. So we're going to make sure to put that in parentheses. So it's going to be 1.35 on the outside of it. When we look at B, it says increase the number by 35%. So with that one, you're going to have 1.35 times your number, x, and then by 5. So in this one, the 5 is not also increased. So you would just add the 5 after. So the wording will have an effect on what kind of answer you get. Okay. So now that you've learned how to solve some basic equations by undoing operations, which we did in section 11, the last section, we can focus on using that skill to solve problems. In this section, we will concentrate on writing an equation. Yes, Mr. Huber. Okay. Yeah. Yeah, 2/3. Yeah. Or students or parents. Yeah. It's all good, I guess. Yay. Good news. Thank you, Mr. Hebron. So writing a equation to represent a situation and then solve it using skills you learned in the previous sections. So to do this, you'll need the skill you just practiced in the explore problem at the top. I apologize if you guys get hungry during this lesson. This has to do with quarter wing night. So getting wings for quarter. All right, so let's read our first example, which we will continue using for like the next 3 problems. A local bar and grill is having a quarter wing night during which chicken wings cost a quarter each. So if they cost a quarter each, we would think of that as 0.25. As you leave home to join your friends there, all you grab is a $20 bill along with your ID, phone, and keys, and also your mask. Yep, I know. Determine how many wings you can purchase if you also want to buy a pitcher of your favorite beverage, and we are speaking non-alcoholic. Be sure to be specific when identifying a variable. In this one, it does help us out and it states what we have. It says W standing for wings is not enough, okay? So we don't want it just standing for wings, because we don't know what that is. Is that the weight of the wings? Is that the cost per wing? Is that the number of wings? So W is going to end up equaling, and they tell us right here, the number of wings. So when we get to doing the algebraic equation, we want it to represent the number of wings. If they don't define it for you, make sure that you do that first thing in a problem. Okay, so we want to find out how many wings we can buy if we have our $20 and we also get a beverage for $5. It does not say anything about tax or tip or dips or anything else. So we're only going off of this information. So if we solve this numerically, we would first account for the beverage. We would take away the $5 and we would have 15. So we've got $15 left. Nothing else we have to worry about paying for at this point. So right now we're just assuming that we can spend the rest of it on wings, which are 25 cents each. So we would get 60 wings. Okay. I don't care if you are like a champion wing eater, 60 wings is going to be a heck of a load of wings to eat. Each turkey has 2 wings. So you're going to be, each chicken has 2 wings. So you're going to be eating 30 chickens worth of wings. That's a bit much. So, and of course we account for other stuff. All right, now the next thing we're going to do is we're going to rewrite this equation and we're going to rewrite this setup and we're going to do it algebraically. So when I think of the fact that we've got 25 cents per wing, that's going to be 0.25 times W, because we have 0.25 per wing. We also know that it's going to end up equaling a total of $20. And the other thing that we need to account for is our beverage. So I'm also going to have 5 in there. If you wrote this as 5 plus 0.25W equals 20, that would be fine as well. But I'm going to use this one as our go-to. All right, let's go ahead and solve it. So I would first subtract by 5 on both sides. And I have 0.25W equals 15. And we end up dividing 15 by 0.25. So you can see that we get 60 wings here as well. Okay. Now, in the numeric approach, it involved dividing 15 by 0.25. This was the same calculation that we ended up doing in the algebraic equation. For the first simple situation, both of these approaches are reasonable. We can agree that, hey, either of these are about the same amount of work other than defining the variable, okay? So for the first simple situation, they're both reasonable and fairly fast. However, it's important to realize that a lot of considerations that would be part of the real life situation aren't in that problem. And the number of wings that you could end up purchasing is quite large and unrealistic. So we're going to start to include some of those details. We're going to start simply, and then we're going to build it to be a pretty realistic situation. All right, so in this one, it says, suppose you would like to buy a pitcher for $5 and also buy, you've got the pitcher and you've also got the blue cheese dressing now for $1.50. And of course, you can use the remaining money to buy the wings, which are still 25 cents each. So this time, I'm going to subtract the $5 and I'm also going to subtract the $1.50 for the dressing. So now I have $13.50 left for my wings. And I'm going to take that divided by 0.25. And I end up with 54 wings. When we do our equation, it's going to look really similar to what we had in the first example, where we have 0.25W plus 5, but now we're also going to include the $1.50, and that will equal 20. If you prefer, you can add those two terms together, the two numbers. You can write it as that or 0.25W plus 650. Either one is fine. Okay, because this one is really similar to solve like number one, I'm going to have us just jump to the next one. Please know that on most of the problems that we have left, I'm going to keep these individually. I'm not going to add them together. And that's so that it matches the context of the problem as it's written. You can always add them together though. You'll still have the same answer. It's still going to be good enough. Okay, for example 3, we're adding one extra thing. Notice that your friend's method, we didn't do that part, so don't worry. We're going to solve the problem again with the goal of leaving a 20% tip after buying the pitcher for $5 and the dressing for $1.50. And we're going to purchase as many wings as possible. So this time I'm going to have us only focus on the algebraic situation. I'm going to have us first start with what we have before, with the 0.25W plus 5 plus, whoa, it's going a little crazy on me, plus $1.50. Now the other thing that we're including is the 20% tip. That gets applied to everything. You don't just give the tip on drinks or dressing or only the wings. So it gets applied to everything. And when we think of a tip, it is an increase of 20%. So that means that we're going to have 1 plus 20% or 1.20. So we're going to be using our multipliers. So everything will get multiplied by 1.20. And that will equal your total amount that you have to spend. So this is your equation. Now we're going to go ahead and solve it. The first step to solve it is to look at what's being done to everything. And I can see that 1.20 on the left is multiplying with everything. So I'm going to divide everything on both sides by 1.20. And then that cancels out that. So I'm left with 0.25W. I'm going to add those together, plus 650 equals, and if you take 20 divided by 1.2, you get 16.67. We'll just round. It would show up as a 6 repeating in the calculator, but I'm just going to round. We'll still get a close answer. The next step will be to subtract 650 from both sides. So I get 0.25W equals $10.17. And my last step is going to be to divide by 0.25 on both sides. So 1017 divided by 0.25 is 40.67. Now, normally if we had 40.67, we would think we should round up to 41. However, you have $20. You don't have anything more than $20, and you want to make sure that you have enough money to pay for it. You don't want to skimp out on the tip or anything else. So we always are going to round down when we're looking at how much we can buy for a certain amount of money. So we're going to have 40 wings. Okay, the last thing that we need to account for in this problem is our sales tax. So to make it the most realistic, we're also going to incorporate sales tax. And with this one, we're going to have the tip also include the tax, because it's going to be easier for us to calculate the tip after we apply the sales tax. And we know that our tax amount, what we get taxed for, doesn't include the tip, okay? Technically, if you guys were to go out to a restaurant, you would look at how much you should tip before the amount before the tax, but for these setups and everything, it's way easier for us to just have both as part of the same equation. So you're always going to have the tip on the outside, okay? So this is something that you want to make sure that you write. Your tip will be outside. So your tax will be on the inside part of it. Okay, so I'm going to include most of my equation that I had before, the 0.25W plus the $5 for the pitcher plus the $1.50 for the dressing. And I know that everything, I'm going to leave a little space in there, everything will end up equaling the $20. Now, for my tip amount, I know that it's 20%, which will be 1.20 because I'm going to be using a multiplier. For my tax also makes an increase in the price. And my tax is 7%, so it's going to be 1 plus 7%. So that's 1 plus 0.07. Whoa. Sorry, the stylus is not working as well as it usually is. Okay, and I know that the tip will be the part that's on the outside. So I'm going to have my tax applied to everything first with 1.07. And then my tip will also be applied to everything. So because I need two grouping symbols, I'm going to use brackets as well. Okay, that is my official equation. To solve this, I'm going to undo what's being done first to everything. So I'm first going to divide by 1.20. So I get 1.07 times 0.25 plus 650. And that is equal to 1667. The next thing that is multiplied with everything is the 1.07. So now I'm going to take 16.67 divided by 1.07. Oops, I forgot to include that W in that last one. And now the right side is equal to $15.58. Okay, the only things left to do would be to subtract 650 from both sides. I'm gonna continue over here because we're running out of room. So if I subtract 650, I get $9.08. And then take that divided by 0.25. And I get 36.3, which we're going to always round down. So I get 36 wings. Okay, this right here, this equation that you have for example 4 is really going to be your model for a lot of the problems that we're doing in this section. And I'm going to show you guys how it's going to be similar. Okay, so looking at the next one, for example 5, it says if the price per wing changes to 40 cents, so now we're changing it to 40 cents, and the price of the pitcher is $5.50. You still have $20 to spend, and it's still 7% tax and 20% tip. So the only things that have changed are the price per wing and the $5.50 price for the pitcher. It also doesn't ask us to include the dressing. So when I write this one, I'm going to have 40 cents for each wing plus $5.50 for the pitcher. I'm not going to worry about the dressing. And I'm going to apply the 20% tip and the 7% tax. The tax is going to get applied first, and then I'm going to apply the tip, and we still have $20 to spend. So that's my equation. To solve it, I'm going to first divide both sides by 1.20. If you want, because we're dividing, you can do this in one step, dividing both parts. Just make sure that you first divide by 1.20 and then you divide by 1.07. So in my calculator, I'm going to take 20 divided by 1.2 and then divided by 1.07. And so on my right side, I get 15.58. And the only thing left over here is 0.40W plus 550. So now I'm going to subtract 550 from both sides. And I get $10.08. And take that divided by 0.25. And we get 40.32, which we would round to 40 wings. Okay. In this problem, what they wanted you guys to do is to get rid of the decimals by multiplying by 100 on everything. I honestly think that we can handle using the decimals. It's just the same thing as doing it with numbers without decimals. You just have to write your decimal places. Yes. Oh, I think I did do it wrong. You're right. Thank you. So we have 10.08 divided by 0.40. Thank you. Thank you. Good catch. 25.2, which would be 25 wings. Thank you, Hunter. So I'm going to have us skip the connection problem because I think we can handle our decimals. Okay, we're going to go through a few problems that will be similar to what you guys will see on the homework or exams, and then you'll be set. So number 7 says, Value Rent-A-Car rents a luxury car at a daily rate of $38.57 plus 5 cents per mile. All right, this right here will tell us the per is what we're going to use with our variable. So, and remember that if this is in dollars and cents, the 38.57, we're also going to write our 5 cents in dollars and cents. So this should be written as 0.05. A business person is allotted $110 for car rental each day. How many miles can the business person travel on $110? The first thing we want to do is say our variable. So this is going to be the number of miles. So we'll go with M. And I know that we're going to have 5 cents for every mile driven. We also have a cost of that, and it says the plus, so that tells us that we're adding those two together. It doesn't tell us to worry about any percent increase like with tax or tip, and we know that that will equal the amount the person has. Okay, those two things are the first things you need. State your variable, and then also state your equation. After that, you just need to solve it. So I'm going to subtract 38.57. So 110 minus 38.57, I get 71.43. And divide that by 0.05. So I didn't include that, sorry. Divide by 0.05. And we end up with 1,428.6. Remember, we're talking about having enough money, so we're always going to, with these situations, round down. So this would be 1,428 miles. after a lady is seated at a restaurant, she realizes that she only has $44. If she must pay 7% sales tax and wishes to leave a 20% tip on the total bill, what is the maximum price of the lunch that she can order? So we don't, in this one, worry about any particular items. We're just worried about the cost of the meal with everything. So we're going to say the total bill before, I'll say T&T, before tax and tip. And we'll have our variable be T. Okay, with this one, we know that everything will end up equaling $44. 7% tax is an increase, so we're going to have 1.07. 20% tip would be 1.20. And we only have to worry about T. Remember that you're going to apply the tip on the outside. Okay, that's your equation. That's your variable. And now all we have to do is solve. And with this one, all that we have on the left side is multiplying. So if you wanted to, you could just do this in one step. Just make sure that you first type in the 1.20. So we end up with 34.267. I want to round down though, so let's say it's going to be $34.26. Because we don't want to be short. Okay, the next one is a lot faster. This one, she's got 170 cash to spend at a music store, and how much can she spend on the items if there's 5% tax? So she just wants to know what will her total be before tax? How much does she have to spend before tax? So let's call this the cost before tax. Call it C. We know that everything will equal 170. And if we've got 5% tax, that would be 1.05. And you can use parentheses or you can even leave them off. Either one is fine. So the only thing you have to do on that one is take 170 divided by 1.05. We get 161.904. So we'll say $161.90. Okay, just 3 left. An online retailer is selling books for $6.49. You have $50 to spend. All right, we know that with these, what you have to spend will end up being what it equals in the end. So I'm just going to write that equals 50. Each book costs $6.49, so we're probably going to be looking at that, multiplying with our variable. How many books can you buy? So we know that the number of books is going to be our variable. I'll have our variable be n for the number of books. You've got 6.5% tax And then it says an additional 10% for shipping. So think of this as like tip. So you're going to apply the 10% after. All right, so if we've got our tax as 6.5%, that's going to be 1.065. And the shipping, the 10% shipping will be 1.10. Each cost of the book is $6.49. We're going to have the tax applied first, and then shipping. On this one, is anything being added at all? No, we have everything just multiplying with n. So here's a trick for this one. If everything is just multiplying with n, we can just go ahead and from the outside to the inside, divide. So first divide by 1.10, and then 1.065, and then 6.49. So just make sure you do it in that order. I'm going to take that 50 divided by 1.1, 1.065 divided by 649. And I get n equals 6.57. And this is the number of books that we can buy. We want to make sure we have enough money. So we'll round down. So 6 books. Okay, she left. Suppose you want to treat your office team to lattes at a local coffee shop. The drinks are $4.75 each. And you also plan to buy a $4 scone. You tip the barista 10%, and you have a 7.25% sales tax. How many lattes can you afford to have if you have $65 to spend? So the number of lattes, oh boy, here we go. We'll have it be n. We know that everything will end up equaling $65. In parentheses, we're going to have what we're purchasing, which is the drinks and the scone. The drinks are $4.75 each, so that will be what gets multiplied with n. And we're just buying one scone. So that will be also applied on the inside of the parentheses, because everything in there will have the tip and the tax applied to it. Okay, for your tip, that would be 1.10. For your tax, it's 1.0725. So 7.25%, your 7 is going to be still 2 decimal places in because it's less than 10. All right, so I'm going to have the tax first applied, and then the tip. Okay, on this one, we're only able to first divide by these two numbers because this number is in parentheses with something that's added. So we're first only going to apply or only divide by 1.10 and 1.0725. So we have 475n plus 4 equals 5509. Subtract 4. I'm going to continue over here. 5109. Divide by 475. And we get 10.75. Round down to 10 lattes. Last one. Suppose that you get a $120 gift card for music. Each song is $1.49. There's also an additional sales tax of 7% in your state. How many songs can you buy with the gift card? So we just have the price per song and the tax. So, and the number of songs is what we're finding. And I know that everything will end up equaling 120. The tax will be 1.07, and each song is $1.49. This one, we don't have anything multiplying with it, so we are able to just divide. And just divide from the outside in. Okay. Divided by 1.07, divided by 1.49. I get 75.268. So 75 songs. You'll now be able to finish up all of those different problems for your 11/13 My Math Lab homework. And I'll post on My Math Lab the deadlines and stuff for the rest of the chapter for you guys as well.